In this video, we are going to start programming. This video in particular is for folks who have not ever programmed before. If you've never so much as written a line of code, interacted with even a place where you would write a line of code, and thought about writing, start here. This is for brand new. If you've done programming before, maybe you've taken a computer science course, maybe you've done some self-teaching, and you kind of get the idea of what we're doing with programming, you can skip this. I mean, it's going to be wonderful and a fine review, but you can skip it and go to the next video, which is Data Science Fundamentals for Programming, which may itself be a review depending on your programming background. But we will very quickly take this course and steer away from programming generally and towards very utilitarian data science related techniques. All right, so what is a computer program? A computer program is literally just a set of instructions telling a computer what to do. That's it. They can get very complicated and they can do really impressive, if not terrifying things if you're following generative AI. But it truly is, at the end of the day, a set of instructions that simply says, hey, computer, carry out these tasks, solve this problem. Specifically, we are going to think about it as problem solving. Oh, I want to find out what the mean GDP of Afghanistan was in 2005. Computer, here's a data set and here's a series of steps to follow to get me that answer. Usually, for more complicated programs, we are going to need to tell it how to solve a series of smaller problems first. So, for example, I might say, hey, computer, I want to find out the GDP of Afghanistan in 2005. Subproblem one is locate and clean up that data so we can make sense of it and import it and all that stuff. Subproblem two is find just 2005. Subproblem three is calculate the mean. The way also to think about programming as you're doing it is that programs should be written as though the computer is not very smart. And for all the computing power in the world right now and all the amazing things that computers are helping us do, think of the computer as not very smart. You need to be way more explicit about what you need them to do. Think of it as, instructions for an intern who's never lived on Earth before. All right. It's a very specific set of instructions. If you miss so much as one step, the whole thing will fall apart. It won't work and you'll be debugging. I will say that just like I spoke about working with data, that you're going to spend way more time cleaning your data than actually doing analyses more often than not. When programming, at least for me, I spend a lot more time debugging than sitting and writing. I do very little sitting and writing. I do a lot of, why isn't this working? Generative AI is something that can help with this, but you're still going to need to do the debugging and you're still going to need to be able to do your own evaluation of whether or not this is working. So even ChatGPT does not resolve us of the debugging problems. But computers are very powerful. Once we get the instructions right, they can crank through things much faster than a human can and much more accurately usually and at a way bigger volume. All right. So an example computer program, we're not going to be programming video games in this course, but if we were, we would say, oh, okay, let's divide the problem of create the world's greatest video game, Super Mario World. Shout out to my Friday nights in high school, by creating subproblems. And the subproblems are going to be, okay, how fast does the character move when you press the over button? What happens when the character runs into an object? What does the background look like? How does it move with the character as the character moves, or does it stay the same? Each of those is a teeny tiny problem. You can kind of think of this as the advice that I never follow in my own life of like, is your goal to write a book? Break it into sub problems, like write chapter 1, write chapter 2. Except when you're programming, you need to be even more specific. You need to say, get out your computer, open it up, open a Word document. Look, I don't do any of those things. My book's going nowhere, but that's the idea. All right. So you could say these are the same problem. You could say these are sub problems that are separate and then link them later. And that is part of the architecture and the art and science of programming. Yay, Super Mario World, pardon me, while I think about how great the 90s were. They probably weren't that great, but boy, they seem great. All right. Programs as recipes is a common analogy. We'll breeze through this, but I would be remiss if I didn't set you up with this if you are brand new to programming, because for as maybe overused as it is in the programming instruction world, it is quite helpful. So think of a program as a recipe for your computer. So, okay, I'm looking to cook the thing in the photo. I don't know what it is. Spinach and red peppers with a side of maple syrup in a jar. How do we cook that? Well, all right, a recipe will tell us, step 1, take vegetables out of the fridge. So even human recipes are not this fine grained. Usually a recipe starts with cut up the vegetables, but we're going to start even more basic. We're going to say, take the vegetables out of the fridge, place them on a cutting board. Now chop them up. Now put oil in a pan. Now put the vegetables in the pan. Now lose interest in the whole exercise, realize how tired you are, order delivery. Shout out to Hunan Bistro right here in New York City. Fantastic Chinese food. Get involved. Tell them I sent you. Tell them anyway. They don't know who I am, but I do order from them all the time. And I have had students at NYU go to them, and I feel, and co-instructors. They're just really lovely. All right. Will this program run? If I were to actually tell a computer, or if I were a computer being told this, will it actually run? Well, the way I've set it up, probably not. You actually need to be even more basic. If we are starting a program from like literally nothing, we're opening up a Jupyter notebook, which is where we'll do our programming, but you're opening up whatever interface you're using to write your code and you have nothing in there, you need to be basic, basic, basic. So you have to say, have vegetables in the fridge, or even create vegetables in the program, or have vegetables you're pulling in from online. Tell the computer it's vegetables. Be able to recognize them. Computer, this is what the pepper is. This is what the spinach is. You can't just say, now chop. You have to say, okay, computer, you're going to hold the knife. You're going to grip it like this. You're going to lift your hand up. You're going to lift your hand down, and you're going to apply pressure and move it slightly to the right. That's not even how I don't know. I don't cook. All these sorts of steps that you need to be hyper specific. As we'll see in later videos, there are ways to, what we'll call in Python, we'll be programming in Python, more on that in a moment. There are ways to import existing program. What is this? Why did that happen? Is that going to happen again? All right, focus. We're going to be able to import packages that have this programming in it. So I could import vegetables, import know how to chop, and then just use that, and that will make our lives easier. If I'm truly being purist, I am writing everything from the ground up. I am God creating the universe, right? So programs written from complete scratch, which we'll learn how to do, is the most granular. You cannot skip, take a step with your left foot, take a step with your right foot, turn and face the counter, and so on. But we could use existing programs like have vegetables, and then we'll just have them. And basically that just means importing someone else's code so we don't have to rewrite it all ourselves. And we'll be doing a lot of both, really. Some approaches to programming include the one we think of, I think, when we think of programming, which is the Mr. Robot, write existing programs from scratch. Or in a way, this is programming, like buy someone else's program completely, fully. Like I'm going to download Microsoft Word and do things with it. I'm kind of interfacing with the program and like creating my own program, which is my document. Anyone who's an actual programmer is like, stop it now. But if I'm using Excel, I'm using someone's program. And so in a way, I'm programming. I'm sorry. Much more common, and we will do a lot of this, is fold existing packages into your own. This is pretty standard in the data science worlds that I am in. Generally speaking, in this course, we're going to do a lot of importing modules, libraries, packages, and we'll talk more about that in the next video. And that's the package that's going to say like, hey, import statistics, carry out this statistics technique. Another thing you can do that I've done a fair amount in my own work, we're not really going to do it in this course, but very common practice as you continue with programming is you say, I'm going to find an existing program out there, whether it's widely used or whether it's one random person on the internet who posted it. I'm going to take their code and I'm going to modify it to do what I want. As generative AI increases, I find that this is also increasing because basically I'll say, hey, ChatGPT, create a program that does this. So it's generated some code. I paste the code in and then I go through and tweak it to make it do more precisely exactly what I want. Just like I might ask ChatGPT to write an essay and then go through and edit it. You didn't hear that from me. Tips for learning to program and frankly anything. So learning by doing is number one. Learning by doing is true for anything we're talking about in this class, but most of all for programming. Do the exercises that I'll suggest as I go. I'll say in a few minutes, hey, try this now. Pause the video. Try this now. Or when the video is done, try each of these. Make sure you're comfortable with them. Go in and try out your own ideas in a blank Jupyter notebook. Practice alongside the reading if you are following the textbook or if you're joining the videos from the textbook. There's a lot of code in there that you can make sure you can do on your own. I also, this is old-fashioned, but I recommend writing out code, especially early on, rather than copy and paste. So the textbook, for example, and a lot of websites with code will have the little snippets of code, and you could just copy and paste them into your notebook or whatever interface and just run them. I strongly recommend actually taking the time to write them out. None of us are doing code that's like so long that would be totally, hours and hours. And it just helps you get a little bit more of a feel for like what you're writing. And I just find it internalized. I don't know. It works for me. Do the homework. There's no homework for a YouTube course, but if you're taking data science for everyone or any other course, do the homework. I promise it's not supposed to just be busy work. It's supposed to be practice. Number two, but more important, equally important. Okay. Number two, don't be afraid to make mistakes. This is Again, I think true for all things in life, easier said than done. But when programming, error messages are your friends. Early on, when we start programming, I was like this. My students are like this every semester. I got an error. I'm bad. I did it wrong. Errors are very common. You get errors, you generate errors in order to get to the right answer. You're testing little hypotheses all the time. You should not shy away from making errors. Errors, error messages, are your friends. We're going to talk a lot about how they're information and you should read them. Too many of my students see the red text in an error message and say, I did it wrong. I slam your laptop shut and go away. They're information. They could be worded more clearly or more in a more friendly tone. They're pretty clear. They could be in a more friendly tone, but they're really helpful. I promise you. You can even read them. Usually there's a message in there for you about what the nature of the error. And take breaks if you're really stuck. Debugging is one of those things where you can really get lost in a rabbit hole and you look up and hours have passed. If you can remember to get up and have a drink of water and walk around the block and look at life, maybe the solution will come to you. Most of all, when programming, build something you're proud of or anything. Honestly, it's building things, it's trying things. We said the same thing at the opening to data science, which is to become a data scientist, get some data and start messing with it. I read, I think it's Anne Lamott's Bird by Bird. A writer is someone who has written today. A data scientist is someone who has done data science today. A programmer is someone who is programming today. I do stand-up comedy, and I was very nervous when I first started about whether or not I counted as a stand-up comedian. And a good friend of mine, great comic, Andy Curtin, said, if you've gotten up behind the mic, you're a comic. Just start programming. The more you practice, the better you get. All right, enough inspirational quotes. There will be more later in the course. All right, so let's forget enough preamble. Let's start programming right this second. Let's go. All right, so here's what we're going to do. In the rest of this video, we're going to do the first 3 of these things, and then in the second video, after this, we'll do the last 4, 5, and 6 of these things. All right, who's this? I'll tell you. It's Guido van Rossum. I'm probably saying his name wrong. He is the person who developed Python. He is known in Python circles as the benevolent dictator for life. I say this just to emphasize that programming languages were written by humans. It's not something that computers instructed us. Like a dude, this guy, very thoughtful, smart, benevolent man, developed a programming language that we use today. In the full class, I talk a lot about why we're using Python as opposed to other great programming languages out there. I'm not going to belabor that too much, but I will say a few words. So Python has been around since the late 1980s. It was implemented in 1989, just like Taylor Swift. 2.0 came out in 2000. I first learned about Python probably in 2006. My friend Abe in grad school ran into the computer lab where we were working. He said, put down your R. I just learned Python. So those of you who are R fans, come at me. I learned R first. Then I switched to Python. They're both very great. If you want to get in an argument on the internet, just announce a preference for a programming language and the people will come. Generally, when we're working with Python, the philosophy is simple, uncluttered, and fun to use. You tell me at the end of it if you think that it is those things, but if you have experience programming Java or other languages, generally Python is relatively simple and uncluttered. If you're coming from R, I'm calling it a purist. If you're coming from R is actually a bit, I think, less cluttered, but I think Python's more fun. There, I said it. Come at me. Oh, it's over. All right. So most importantly, why is it called Python? It's because of Monty Python. Hooray. Too many people think it's because of the snake. Monty Python, if you don't know them or their work, fix that. Take a look. Monty Python is amazing. This is the 20 aphorisms that are the guiding principles for Python's design. You can get really in the weeds of Python. These are the 20 aphorisms, but only 19 of them have been written down. Ooh, mystery. All right, let's go. In this course, we are going to be working with Jupyter notebooks. If you want to use Jupyter notebooks, you can download them. The textbook has some directions on how to do it. So this is a Jupyter notebook, not the only place you can do code, not the only place you can do Python coding, but it's the place that I think, again, is one of the easier and more straightforward places to begin. You're going to open up a Jupyter notebook and you're going to get a single cell that you can fill in. And here I've filled in, oh my God, I'm coding. I just wrote words. What happens? Well, I run the cell, so I could go to the run button, the little play button there, or I can press shift and return. I promise you want to get in the habit of typing shift and return to run the cell. And let's see what that does. I told the computer that. I get an error. Okay. My first start is an error. That's good. Errors are good. Syntax error. So because I know how to program, know what's going on here. What I need to do is say, okay, computer, print parentheses, quotes, oh my God, I'm coding, and it's going to print, oh my God, I'm coding. We'll break down why that works that way as we go. But the idea with programming is you have to speak it in the language that the computer likes. And in this particular case, if you want the computer to say something that you are giving it, and those things that you're giving it are words, you need to follow the syntax of print, parentheses, and put it in quotes. Have your Jupyter notebooks open. Some very quick examples of things you can do. It can be a calculator, right? Just perform arithmetic. You don't need to set it up in any special way. You can just write numbers, 12 plus 6, 12 minus 6, and so on. So just try it out and get a feel for it. Nothing fancy, but just to get used to the feeling of doing it. By the way, putting a hashtag and following it with text is called commenting out some text. So in here, I've added some annotations: addition, subtraction, division, multiplication. This is notes for myself so that I can say, what was it that I was doing back there? In this particular case, I obviously don't need it. But in other cases where my code is more complicated, it's very helpful to say, what's this one doing? Oh, this is finding the mean and then subtracting the right? You can also use it if you're going to share your code with others. It's a good practice to say like, hey, this is what's happening, or this is why I'm doing it. Super helpful. So super great habit to start, even if right here it feels somewhat silly. More arithmetic, a couple of little things to know here. You can do exponents with 2 asterisks. You have a little bit of flexibility with spacing, but not a ton. And the usual order of operations with math applies. I'm going quickly because this is straightforward. And truly, I say pause the video and start messing with it on your own and just write out a handful of arithmetic expressions and just see for yourself. Get a feel for it. Yay. Yay. All right. Naming. This is basically, we're just naming something. So I can say that some variable or some expression is called something. So I'm going to say, previously I solved 12 plus 6. Now I'm going to say, okay, I'm going to create a variable cost, and that cost is going to contain 12 plus 6. So cost is now 18. Yay. And I can use it like I would use a number. So 100 minus cost is 82. Income equals 100 minus cost. Income is 82. Again, this is all very trivial, but when we work with data sets, we are going to often want to name something that contains a lot of information and then be able to manipulate just that thing. Another example is I can create an equation where I turn numbers into words kind of for my own keeping track of things. So this is an example of turning a calculator to find the total price of something equals the price plus the price times tax. And now I have a little program where I could just update the price and update the tax and generate a total price. So anytime I go shopping, I can now predict how much my groceries will cost if I have my Jupyter notebook open. Yay. Make sure you're practicing. Super simple. I promise you it's worth practicing. Finally, for this video, we'll talk about functions. We'll come back to these. There are built-in functions in Python. This means it's pre-written little bits of code. If you're using Jupyter Notebooks, it's going to show up in green when you type it, like here where it says ABS. That stands for absolute value. And if I type ABS parentheses -6, it will find the absolute value of 6. It will find the absolute value of whatever I put in those parentheses. This is so we don't have to write it ourselves. We don't have to create later on. We'll be creating functions. This is just built into Python, and you don't have to do anything special. It just works. Here I've created ages that contain some numbers, and I can use a built-in function called max that's going to tell me the maximum number of these 4, which is 16. And min does what you think it does. You can also do it without creating ages and just put those numbers right there. So we're just putting together little basic pieces. This is going to be the backbone of a lot of what we do. So make sure you're just like able to do this in your sleep. Try experimenting with others you can think of. Abs, min, max seem pretty straightforward. Are there others? I'll post a link for this in the video notes, but Python has official documentation on all the built-in functions that there are. The very last thing I want to say is this is the intuition that I really want you to build that's more important, frankly, than memorizing different bits of code, is learning how to find out how to code something. So suppose I want to find the mean of those 4 numbers that I called ages. Is this going to do what I think it's going to do? Why or why not? Well, I said moments ago that you need to have green font for it to be a built-in function. So we have a hint that it's not a built-in function. And lo and behold, we get an error that says mean is not defined. Well, it's not a built-in function. It turns out if I want to calculate the mean, I have a few options. One, I could do it by hand. I could say, go back to the values that were in ages and add and divide by 4. And I am just telling you this so that you know that it's out there. And as you get more familiar with Python, you'll learn more and more at different places you can look for these sorts of things. But what I can do is import a package. More on this in the next video. Import a package called statistics, within which it has a pre-written block of code that calculates the mean. So if I import a package called statistics, and then I call the function statistics.mean, and I put my numbers in there, I am going to get the mean. I could also import just that little sub bit. I could say from statistics, import mean, and then I can just say mean without having to specify statistics. So I don't know about you, but 22, okay. When I am programming, I often go from like, I get it, to like, wait a minute, what? Like way too fast. And I feel like this moment might be the case for some who are really, really new. And so don't worry about it. We'll come back to this. Just take this code and literally write it down. It can feel very overwhelming, but just try writing this out and get a feel for it, and it will come, I promise. There's another package out there that also is helpful. One is called the math package. So I can say import math. And in this case, if I want to find the square root, I can type math.square root. Notice that import and from are all in green. Those are built-in functions. And just like above, I can say from math, import square root. And then from then on, I can just write sqrt and find it. Again, I'm just sort of telling you these packages are out there, but much of your life as a Python programmer are going to be getting familiar with particular packages within the Python language. All right. Whew. That was a lot, but you've gone from never programmed to just did a whole bunch of stuff. Awesome. I'll see you in the next video.